Okay, in this video, we're going to look at the third rule, the chain rule. Before we go looking at that, however, we just need to touch on a couple of things that may come up in the questions. So first of all, how to deal with a square root sign in differentiation. So where we have a function like this, where y is equal to the square root of x, we can't actually apply our differentiation rules directly because of the square root sign. Remember, differentiation is all to do with applying rules to powers. So we must actually rewrite the square root sign as x to the power of a half. Once we've done that, we can now apply our normal differentiation rules. So we can look at bring down the power and multiply, reduce the power by 1. So that is a half by x to the power of minus a half. A half minus 1 is minus a half. So once we've done that, we can either leave it as is, or we can tidy it up a little bit. Tidy it up, that would simply be 1 over 2x to the power of plus a half. But leaving it in this format is fully acceptable because you'll be able to work with this format. So that's one type of question that can come up on occasion. Another type of a question that can come up is, say for example, we have a question like this where we have y is equal to 1 over x squared. Now we can deal with this using our quotient rule if we prefer, but because we have a single fraction with 1 as our numerator, we can actually write that as x to the power of minus 2. So we're using the same idea that we're using here. Using our index rules, we're bringing that x to the top of the fraction line, but remember when the power comes up, we change it to a negative power. Then when we're differentiating this here, the minus 2 comes down, so we have minus 2x to the power. Here's what we have to be careful of. If we're reducing the power by 1, that goes down to a power of minus 3, not minus 1. So be careful about that. So that would be our final answer, or what we can write it as is minus 2 over x cubed. Either of those formats, again, is fully acceptable. So I just wanted to mention that before we went on to the chain rule so that it is fully clear in our minds in terms of answering the further questions. Right, so chain rule. So sometimes we have a complicated function, so it's kind of like a function within a function. So say, for example, I have the function y is equal to 3x squared minus 4x all to the power of 7. Now, unfortunately, in terms of multiplying this out, it's going to be quite complicated because we have a power of 7. We don't want to waste our time in multiplying that expression by itself 7 times. So we have to have a way of dealing with it, and that's where our chain rule comes in. So what we do is we replace the complicated part of our function with the letter u. So we can rewrite that as y is equal to the part that's causing us difficulty here is the bracket. So we're going to place that bracket with a u. So now we have u to the power of 7. Where u is equal to 3x squared minus 4x. Now the problem with this is we have information in terms of y and u, and information in terms of u and x. So we can differentiate these separately, similar to what we've been doing with the product and quotient rule. So if we look at this one here, if we differentiate y with respect to u, we get dy du. We bring down the power and multiply, reduce the power by 1, so we get 7u to the power of 6. If we look at this expression here, we can find du dx. So bring down the power and multiply, reduce the power by 1. So we have 3 times by 2, which is 6x, and we have minus 4. All right, so from this here now, we have dy du, and we do have du dx. But what we want is dy dx. So if we look at what we have here, dy du and du dx, because there's a du on the top and the bottom of the fraction, if we multiply these two fractions together, the du over du will cancel each other out or eliminate, and you are left with dy dx. So all we need to do is simply multiply these two expressions together. And we must remember that because we want our answer to be in terms of y and x, we are going to reverse our earlier decision of replacing the bracket with a u, and now we're going to replace our u back with the 3x squared minus 4x. So we have 7 by 3x squared minus 4x to the power of 6 multiplied by 6x minus 4. The only thing we can do to tidy this up is multiply the 7 by the 6x minus 4. So 7 times by 6x is 42x. 7 times by minus 4 is minus 28. And we are multiplying that by 3x squared minus 4x to the power of 6. And that is our fully simplified answer. We can't actually simplify it any further than that. So that is one representation of how we use the chain rule, right? So now there is a bit of a shortcut here, right? If we look at what we've done, the traditional rule of differentiation applies to this section here of our derivative. So we have brought down the power and multiplied, and then we've reduced the power by 1. But we have to have a way of coming up with this. So the shortcut is bring down the power and multiply, reduce the power by 1, but then you must multiply by the derivative of whatever's in the bracket. So in other words, the derivative of this bracket here is the 6x minus 4, and that's why we have to multiply. But for those of you that can't remember that little bit of a shortcut, this is how we would structure it out, and sometimes it is better to show exactly where your answer is coming from. I'm going to look at another question on that chain rule now, just to make sure that we understand it fully. So if we look at this question here, we're looking at y is equal to the square root of 3x cubed minus 1. So again, we're dealing with a square root sign. The first thing we need to do in order to be able to differentiate the square root sign is change that square root sign to the power of a half. So we're going to change that to 3x cubed minus 1 all to the power of half. Now, again, we have a complicated function. We have a function within a function, if you like. So what we can do is replace that with a u, where u is equal to 3x cubed minus 1. So we take away the complicated, whatever part of the function is causing us difficulty, we remove that and replace it with something more manageable. So again, differentiating separately here from this expression, we can get dy du, which be a half u to the power of minus a half. From this expression, we can get du dx, which is 9x squared. And then our final answer is to multiply them together, because remember, dy dx is dy du multiplied by du dx. So if we want to start off by saying it's a half u to the power of minus a half multiplied by 9x squared, then we can start tidying it up. So 9x squared as a fraction is 9x squared over 1. If we like, we can bring that u to the bottom of the fraction. So what we have is 9x squared over 2 times by u to the power of a half, and u, remember, would be the 3x cubed minus 1. So that there would be our final answer in terms of our fully simplified derivative. It can be a tricky rule to get your head around, the chain rule, so it is important to practice it a good bit and take your time with it. Like each of these steps, you'll be getting marks in your question, so it's important to show each step along the way and make sure that you break it down fully, all right? One other thing that I want to add on to the end of this video is higher order differentiation. So we've looked at finding dy dx. So we've started off with a function, say for example, y is equal to x cubed, and we have found dy dx, which is our first derivative or our slope of our function, which gives us 3x squared. Higher order differentiation just involves getting the second derivative, the uses of which I'll go into a little bit later in further videos, but for now, all we need to do is be able to find the second derivative. The second derivative is called d2y dx squared. And what we do is we simply differentiate a second time. So our first derivative goes from our function to our slope. Our second derivative goes from here and differentiates again. So we apply the same rules, bring down the power and multiply, reduce the power by 1. So that would give us a 6x. So that is something that can come up on occasion in the questions. We won't worry about the uses of it just now, but in terms of finding our second derivative, it's simply differentiating for a second time. Thank you.